This is going to be a fun video. Alright, how Earth's oceans form. Alright. Now, what you have are stars being the planets. Those who haven't read the theory, the circular objects, they're spherical, are one and the same. There is no difference between the two. Unfortunately, establishment has separated stars from planets, being that these shine and these don't. What they don't realize is these will stop shining and become these. So there's your PhD thesis. When it comes to forming oceans, what I want people to realize is that stars have hydrogen and oxygen. All stars have that. Yay! They have lots of hydrogen and they have lots of oxygen. When the star cools, okay, what happens is the H combines with the O and another H and releases heat. We call this an exothermic reaction. And depending on what stage the star is in, will determine when the water combines and cools and falls to the interior of the star. For instance, if the star is cool enough, the water will fall towards the center. And there will be a little magma, rocks, minerals forming in here as well. And the water will cool that and form the interior crust as the star evolves, and all the other material is falling on the interior of the star. So in other words, as the water is synthesized in the top portions of the star, it falls inwards. And since it has a high specific heat capacity, it can store a lot of heat. Water is very special like that. It can become superheated, and as long as it has enough pressure, it can store a whole lot of heat. And over time, these outer layers of the star will start evaporating. Okay? And the water will just stay put on the surface of that blue dwarf star. This is the water. Of course, here's a thicker atmosphere. And at least one time in the star's evolution, it will have very thick oceans. It'll be an ocean world. Ocean world. And it will stay like that for some time, depending on its proximity to another host star, or even maybe a binary system, okay, which it will orbit. This is the much older star. Basically, that's how oceans form in stellar metamorphosis. The star cools, combines the hydrogen with the oxygen, forming water oceans, which then stay put, and the star, that's it. You know, there's the oceans, which then evaporate away into interstellar space, and what's left over is just a rocky ball. There's nothing, it's like Venus or Mars or Mercury, it just floats around, transferring from solar system to solar system. Now, the really strange part is the establishment of science. Here's how they form oceans. This is Earth. Okay? What they do is they just have random comets hitting the Earth. At some point, 4.5 billion years ago. Which Which begs the question, how did the water form to begin with? Where did it come from? Where did it come from? And as well, if water came from comets, that should make all comets watery, icy objects. Now, if you've been paying attention to the Rosetta mission, you'll know comets are a 3-letter word. Comets are dry. So what that means is that this comet theory of transportation of water to the Earth doesn't work. Not only that, but if that theory were true, one could question the fact that Mars doesn't have oceans. Where are the oceans on Mars, if this was supposed to be true? Where are the oceans on the Moon? Where are the oceans on Venus? Where are the oceans on Mercury? Maybe we'll give that one because it's too close to the sun. Maybe the oceans have already evaporated. Because if all these objects, Earth, Mars, the Moon, Venus, Mercury, all formed at the same time from the same process, you would expect them to have oceans as well. But since we know that that's not true, clearly Earth is a part of an adopted family. And these objects are inside of one stage or another of stellar evolution, and the current arrangement that we have in the solar system is nothing less than an adopted family. The objects in our solar system all came from somewhere else in the galaxy, and they're all in one stage or another of their own evolution. The Sun being the youngest object, adopting all the others. I guess that talk sums up the formation of water, oceans. All stars will have them along their evolution. Some will evaporate quicker than others. Some, like Earth, we got lucky. We get to keep ours for a little while longer. All right.